Hello everybody, I will start my today's coding practice. So today's question is this one, 3 sum. So in this question, I will be given an integer array nums and return all the triplet where I is not j, I is not k, j is not k. So I will pick the distinct 3 numbers and all the numbers sums should be exactly 0. Notice that the solution set must not contain duplicate triplet. So ijk should be ordered or not. I'm not pretty sure on that. And also I'm not pretty sure what does duplicate triplet means. Say if I have 1, 1, 2, 2, 3, 3. Sorry. So if I have 1, 1, 2, 3, I'm not pretty sure. This means that I shouldn't return 1, 2, 3 and 3 to 1. Or does it mean 1, 1, 2 and yeah. It just means 1, 1, 2 should occur, sorry, 1, 2, 3 should occur exactly once. Yeah, so I'd like to confirm that also. Yeah, so I just listed the question, which I came up with just reading the question. But let me look at any examples and yeah, understand the question statement more. Okay, so that being said, I will read the examples. So if I give a negative 1, 0, 1, 2, negative 1, 4, what I should return is negative 1, negative 1, 2. So it seems like order doesn't matter. However, I should return exactly one combination. So in this case, negative 1, negative 1, 2 is returned, but negative 1, 2, negative 1 is not returned. So I will think of the unique combination and I will return exactly one permutation of that combination. So that's my understanding with that. Okay. And as I can, as this example shows, the sum of the 3 numbers, triplet, is 0. Okay. And for example 2, I will be given 0, 1, 1, which doesn't have any triplet whose sum is 0, so I will return an empty array. Okay, I see. So let me think how I can solve this question. So let me think with an example like this. I don't know. Yeah. So I think the brute force approach I can take is, so I will pick one number. I will pick 3 numbers. Yeah, every possible 3 number, and then I will take a look at the sum of each of the triplet, and if it is 0, it can be included in the answer. Firstly, I will just think what kind of triplet can be like that. And when I take 3 numbers, I don't take the duplicate triplet. That being said, so like this, and I will make sure that. Oh, however, it is possible that if I do that way, it can contain duplicate triplet. So after that, I will make sure that I will sort each triplet 3 numbers and create a new sorted triplet from that. Then I will use the set to ignore the duplicate and get the correction of valid triplet. And then I will return it into the list and I will return it. sorry, I will convert it into the list and I will return it. So if I take that way, the time complexity should be n triplet, I mean n cubed, because I think of n cubed combinations. Then for each, I will sort it with the constant time, and then I will push each of them into the hash set and then convert it to list. So they're n cubed triplet, and I have to add them into set and also add them converted to list. So in total, it will take n cubed time complexity with and space complexity is also the same, because as I said, I have n cubed triplet, and all of them are in the list or in the set. Okay. And that being said, another approach. Okay, I will somehow optimize this solution. So what I have in my mind is when I have this number, then from here, what I will search for is two sums which should be -1. So if I take 1, then from here, I will take a combination whose sum should be -1 in this range. Then after that, I will move the first pointer forward by 1. Then if I have 2, I will search for the combination, two pair of numbers whose two sum should be -2. And if I find such numbers, then after that I will put it into the set. Sort it and then put it in the set and then convert it into the list. It's the same thing as what I did in the brute force approach. Okay, so in this way, it will take n squared time, because I will pick one number, and then after that, finding the two sum whose sum is -1 should take O of n. Because when I traverse the pointer, all I have to do is keep the seen numbers into the set. And then say if I have -2 in the set, then if I encounter 2, then I can create the sum. Sorry. So, and assume that I'd like to create the two sums whose pair of numbers whose sum is 0. In that case, if I encounter 2, I will look for -2 in the hash set, and then I can find it in the constant time. And so in that way, the time complexity to find the two sum whose sum is -1 will take O of n. So I have n, the first pointer I have n, I will traverse the first pointer, and it will take n, iterations type it n times, and for each it will take n, up to n. So in total, it should be n plus n minus 1 plus n minus 2 plus blah 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 1, which is n squared time complexity. Okay. For space complexity, it will take n triplet, because I will put all the possible, I just have to keep track of all the answers. So I don't know actually how many answers it can be at max, but assuming that every combination can be that, n times n minus 2 minus n minus 1, which is n triplet. Wait, I think it can't be. Wait. Oh, okay. So okay. So let me just dive deeper into the possible number of answers. If I take 1, max number of pairs I can take whose sum is -1 should be the remaining number divided by 2. Yeah. So it should be n. I mean, yeah. Because I will find the pair like 2 and 3. And if I pick one number, the complement is determined exactly. Yeah. So that's why it should be n squared. Max. Okay. So that means, sorry, n divided by 2, n out of 2. So in total, it should be n squared space complexity. Okay. Let me think a bit more. Maybe I can do it a little first faster. What I have in my mind is sorting this array first. Sorting takes n-log-n time complexity, so there is a possibility that I can, speed up. Yeah. So I think I can use kind of 2 pointers combined with hash set. So what I just come up with is, firstly, I will keep all the possible numbers here. Oh, no, it doesn't work. Yeah, I thought I will move this and this, and then I will look for the remaining number, remaining complement from this set. However, it will take n squared time. Okay, I will implement solution 1 first. Optimize first approach. So as I said, I will first retraverse the first number, and then the two sums should be, minus I1. Then what I will do is find I2 and I3 whose sum is exactly 2 sum. So And the complement should be 2 sum minus nums I1, I2. Oh, sorry. I think I don't need this 2 sum variable here in line 41. Let me just say I think this is more intuitive. So first three, triplet is this and this and this. Then I will sort it and convert it to tuple, and then I will put it into the returned triplet hash map. Okay. Then what I will do is I will put the nums I2 into the scene set. Okay, then I will return the set after converting it into the list. Okay. Just keep in mind that in line 42, scene set is reset exactly when, every time the first number, picked up first number is changed. Let me walk through my code with example. With this example, and it gives us 4, so I will pick I1 as 0, then 1 and 2 and then 3. And first 3, scene hash map is begin with the empty set. Then for I2, when I take 0, it will begin with 1 and move till 3. Yeah. Sorry. And when I2 is 1, complement is negative num0 minus nums1, which is negative 1 plus 2 is 1. This is the complement. And because scene set is empty, I don't do anything, and I just add this nums I2, which is negative 1, to scene set. Then I will move the I2 index, and then now complement is negative 1 minus 0 is negative 1. And complement is not in scene, so I will go to line 48 and I will put negative num which is 0 into the scene set. Then when I wait a minute. Okay. The one is picked up. Yeah, and when I2 is now 3, index 3, so nums index 3 is 1, so complement is negative 1 minus negative 1 is now negative 2, and it is in the scene set. So the triplets should be 1 and negative 2 and Oh, sorry, num_site is 1 and negative 2. And this is sorted into negative 2, 1, 1, then converted in tuple, and then it will be added to return the array. So now return the array is negative 1, 1, 1. Okay, good. And after that, I add nums_id, which is 1, to set. Scene set. Okay, good. So I will keep this until, for I1, 1 and 2 and 3. Let me just finish with this because I've covered all the code and I'm pretty sure on this code. So I will submit my code. Good. Okay, so now it's time will be dictated. This is because in the constraint, number of elements is up to 10 to the power of 5, so n squared solution is not accepted. Let's think how I can solve this, in optimized way. Probably I can sort it first. I don't know, but at least sorting takes NlogN time, and I can think of it faster than squared, so it can be useful. Let me think. I see. So after finding the first number, I will do the 2 point. No. So after finding first number, wait a minute. No. Because numbers are sorted, I can use binary sort. Binary search in this sorted array. I don't know if it can be useful or not. So wait a minute. So if I pick first number, then I have to find two sum, whose sum is 3 with LogN time. I will look for two sum whose sum is 3. Wait, so what I've just come up with is if I pick negative 3, I'd like to get all the pairs whose sum is 3. So if I have such pairs in the hash map, it good. Wait a minute. Oh, sorry, wait a minute. Num's ranks is 3,000, up to 3,000. I think NlogN solution is accepted. I don't know why this didn't work. Hmm. If this is 000, let me quickly check what happens if I skip the operation. If this is not in return array, return set. So it does make difference. Okay. Wait a minute. Num's rank is up to 3000, but this solution was not accepted. I don't know why. Okay. If I pick -3, I have to find 3, and it can be 1, 2, or -1, 4, or yeah. If I get -3, as I said, I would get 1, 2, 1. Wait a minute, so okay, so wait, n squared is not accepted. So what I just come up with, if I traverse 2 pointers first, or let me see, if I move the middle pointer, no, it was 30 squared. So what I was thinking is, if I move the middle pointer, I mean second number in this way. Say if I'm here, I will look for all the pairs whose sum is 1. Wait, but as I said, I think number of elements sum whose sum is 0 should be n squared at max. And in that worst case, is the time complexity should be n squared. They said. Mm. Let me see this time limit exceeded case. All of them is 0. So in this case, the problem is, yeah, in this case, I traversed. Yeah, even with 0 of the 0 very long array, time complexity should be still n squared. So why it took more than that? I mean, time limit exceed. Oh, wait. So maybe? No. Return is set. So I thought maybe the list of possible triplets is very long and not exactly. Wait a minute, so I really don't come up with a good solution here. So let me read the hint. Can we change the arrays? So idea is sort it and then do the binary search. But still I think it takes n square. Yeah, if I do the what it means. Yeah, I think I can do the 2 pointers. So say if I pick one, then I will use pointers here and here. Then if some of them is -1, it's good. So in this case, I will take a note of this pair, and then I will move the second pointer. Then because this is smaller, oh, this is not sorted. Sorry. So firstly, I will take -1, 5. And because the thumb is larger, so I will move this bigger pointer, larger numbers pointer by -1. Then because this is larger, still larger, I will still move the right pointer. Oh, sorry, no, for -1. In this case, sum is 0, so it's okay. The sum is 3, so I will take note of -1, 3, no, 1, 4. Hmm? Yeah. And then after finishing it, I decide to move the right pointer. Then here, because it's still the same, so I can move this pointer. Yeah. Then it's still the now the sum is 0, but the combination is the same, so I will move right pointer again, and now it's the sum is 2, so I will move the right pointer because triplet sum is larger and I have to decrease the number. Now I guess the sum whose number is smaller, exactly whose sum is 0, I will take note of it. Then because I did so, I move the right pointer, and then now sum is 1, so I have to move the right pointer, and then right pointer and left pointer and counters, which means that I can take any more pairs, so it finished. But with this, I think it would still take n squared. Yeah, let me quickly implement this and see if it is accepted. So, and because I have to take two numbers, I have to do moves first index by n-3 index, n-3 in 0 indexed. So, and that being said, the two nums should be I will start the 2 point with these partitions. Yeah, again, I think I don't need to some variable. So if the triplet sum is 0, I will keep it in the return triplet set. Okay. Then after that, I will move I1. Otherwise, if this is smaller than 0, I will move the, because the sum is smaller, I will move the item. Oh, sorry. And otherwise, because triplet sum is larger than 0, I will move the start pointer. Okay, and finally I will return the list of all the possible, triplets. Okay. Let me quickly check my code. Okay. Yeah, I'm pretty sure of my code, so I will submit now. Oh, sorry. So I will find this out. Ah. And I will run my code. No, this is still time limit exceeded. So as I said, this solution is still n squared. Hmm. So as I said, I'm looking to some Hmm. Ashma. Second try of the wait, maybe my hmm. 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 Let me read the hint again. So we essentially need to find three numbers by z such that they add up to the given value. If we fix one of the numbers, say x, we are left with two-sum problem at hand. Yes, what I did. For the two-sum problem, if we fix one of the numbers, say x, we have to scan the entire array to find the next number, y, which is value minus x. You have to scan the entire array to find the next number y, which value minus x, where value is the input. So in this question, yeah, hint 2 is talking just about the two-sum question. And hint 3, the second train of thought for two-sum is, without changing the array, can we use additional space somehow? Like maybe a hash map to speed up the search. I think I did this, right? Let me read the editorial. So this first approach takes n squared time, and the second approach takes also n squared time, third approach n squared time. But they are accepted, even though mine was not accepted. Why is it? Let me stop my video and come back after I read the answer. Okay, so now I've come back. So I find how I can, make this question, solve this question is accepted. Yeah, so approach. So all I need is this line. When the triplet sum is exactly 0, I increment lower pointer I2 and decrement higher pointer I3 at the same time. Only with this, my solution is now accepted. Yeah. And I think for the three-sum approach, in here, round 74, maybe I can skip the operation if no. Oh, sorry, I just forget. Yeah, so this is how I could avoid time limit exceeded in the first approach. I mean, optimize 2 approach, which is this sorting plus 2 pointers. Let me think of it and let me write the reason why in the description of this YouTube video. Okay, that being said, I will quickly wrap up this question and finish my today's coding practice. So this is a three-sum question, and my task is to find the triplet whose sum is exactly 0. And for the brute force approach 1, I came up with picking every combination of triplet and then check the sum, which takes n cubed time complexity. And I also came up with 2 more approaches, each of which takes n squared time. The first approach is like the two-sum approach. So, deciding the first number and then find the pair whose two sum is exactly negative first number. Yeah, but this was time limit exceeded. I don't know why. And another optimized approach was to use sorting plus 2 pointers. So in this approach, I firstly sort the array and pick the first number, and then for that number, I will use the 2 pointers to narrow down the, or I should say, yeah, I will use 2 pointers to find some pair whose sum is negative first number. Yeah, and in this 2 pointers implementation, I had to increment lower pointer and decrement higher pointer, both of them, when the current triplet is valid 1. So with this, its time limit exceeded. I don't know why. Yeah, but that being said, let me finish my today's practice with this. Thank you so much. Bye.